Welcome to this week's lab exercise for Microsoft Excel in Health Science 391. So for this week, we're going to be continuing along the same lines as we've done in the past. We will be building a model that we'll use Excel to do this. And with each one of these, we've been trying to make things a little bit more advanced and a little bit more complex. So we're kind of ramping up our skill levels. So with this model, it's no different. The formulas will be a little bit more complicated and advanced, and we'll be using some additional functions that we haven't used before, as well as some additional functionality in Microsoft Excel that we haven't used before. So again, we're going to just use this as an opportunity to explore some of this new functionality. When you're all done with the model, you'll save it. This again will be also part of your existing workbook, so make sure to put this into the workbook that we've already created, and at the conclusion of this you'll be uploading that into Canvas, and that will constitute your participation credit. So it'd be the same as my taking roll and you saying here and my writing it down. So let's talk a little bit about what we're going to be doing. And before we do that, I want to preface this with a note here, and that is that we're going to be building a model that estimates the amount of compression force that's exerted on the lumbar region of the spine when a person lifts an object. For purposes of this class, you don't need to know anything about spinal compression force or anything even related to it. This is a physical therapy topic typically, or a biomechanics topic in kinesiology. It's not really related to the course, other than it makes a really convenient example to build a model with, because the formulas are about the right size and length that I'm looking for and the right degree of complexity. They work out really well. So if you're wondering, is any of this going to be on the exam for the final? No, not as it relates to spinal compression force. You don't need to know anything about that in order to pass the exam or do well on the exam. But you will need to know about the Excel concepts that we cover as we build this model. But it is important to understand a little bit about how the model works, so that as we're building our Excel model, we have an idea and an appreciation for what it is we're trying to accomplish. If something goes wrong and you have no idea what this thing is built to do or designed to do, it's going to be really hard for you to troubleshoot. So we'll talk a little bit about how it works, and it's not really all that complicated. The idea behind this model is that it measures the amount of compression force exerted on the lower part of the spine. That's the lumbar region. And compression force is kind of defined as sort of like a squeezing force, upper and lower. It's kind of pushing in two directions and squeezing the vertebra on the spine together. In between the vertebrae, you've got discs, and if there's too much compression force exerted, those discs can become herniated, where they get squeezed out of place, or they can become ruptured, where you actually kind of lose that padding in between the bones, the bone structure of the vertebra. So that's generally a source of low back pain and back injury when that happens, when those discs become injured or damaged in some way. So what we're going to do is we're going to try to measure the amount of compression force that's exerted when an individual lifts an object. Now, our model takes 4 input values into consideration, and those input values are then used to try to quantify and to come up with actually a number that we can assign to that compression force. If we know what the maximum amount of compression force is that can be exerted before an injury is likely to occur, it kind of gives us a way to quantify the risk factor, at what point somebody is risking a back injury. This model, by the way, is used in physical therapy. It's used in workplace injury prevention programs, used in lots of different environments. So it's one you may encounter at some point if this is an area that you work in. So the 4 input values are the following. First of all, the weight of the object being lifted. So the weight in pounds is going to make a difference here. The heavier the object, obviously, the more compression force that can be exerted on your spine. So that becomes one of our input values. Next is the horizontal distance from the hands to the low back. So if you think about somebody lifting an object, like in this illustration here where that arrow is pointing, in this example, the person's hands are mostly outstretched, holding onto the box, but the further out that their hands are, the more of an effect it's going to have on the compression force. So what this is doing is it's asking the question, how far away from the low back are the person's hands? Are they really close, or are they pretty far away? Next, the orientation of the back. And there's essentially two extremes that we see in these two illustrations here. One where the person's back is straight and the person is using their knees to lift. This is what my wife, the physical therapist, always tells me I'm supposed to be doing when I lift an object, is you keep your back straight, you bend your knees, and then you use your knees to stand up. Or you're bent over in the second illustration, and that would be kind of the alternative. So we have numbers that we can use. This is actually quantified using a cosine theta. And if that's not your thing, don't worry about it. It's actually pretty simple. We're just going to plug some numbers in depending on the orientation of the back. And then finally, the body weight of the person doing the lifting. And this makes a difference. Whether the person tends to weigh more or less, it's going to have an influence on that compression force. So that becomes our fourth and final input value. Now, our cosine theta values are the following, and this is for the orientation of whether someone is standing up straight, in which case they're vertical, and in that case the value would be a 0. If they were 1/4 of the way bent over, that would be a 0.38, halfway 0.72, 3/4 of the way 0.96, and if they're completely bent over, like this guy is here on this bottom left-hand corner illustration, that would be a value of 1.0. So this is how we're quantifying that angle in the back based upon these values. Now, the formulas we're going to use look like this. We have 4 formulas. And this is actually, believe it or not, actually one big ugly formula. It's actually a multiple regression formula, but what we're doing here is we're simplifying it. We're breaking it down into 3 smaller formulas and then adding the results together. Makes it a little bit easier to program and a little bit easier to look at. So we have a formula A, a formula B, formula C, and then finally we have our final compression force formula. Formula A is 3 times the body weight times the cosine, and that gives us the value for A. Formula B is 0.5 times the load weight times the horizontal distance from back. That's what HB stands for, horizontal distance from back. That gives us the results for B. And then finally C, this one's a little bit uglier because we've got some multiplication, division, and addition all going on inside the same equation. So we need a couple sets of parentheses to set the precedence or the order of operation properly. So it's going to be the body weight divided by 2, that quantity added to the load weight, that quantity multiplied by 0.8. And that will give us the value for C. Finally, we have the final compression force formula, and that will simply be A plus B plus C. We take the results of those 3 things, add them together, and then that will give us our final compression force formula. So in a nutshell, those are our formulas. Now, next step, we're going to go ahead and fire up Microsoft Excel, and we'll take a look at how this is going to work. Okay, we should now be back in Microsoft Word using our Excel workbook that we've been building our other models in. And I'm going to go ahead and start by creating a new sheet. So go ahead and press your New Sheet button to create a new sheet. And depending on the order that you've done this in, it may call it Sheet 1 or Sheet 2. On mine, it happens to have called it Sheet 2. I'm now going to rename that. And for this one, we're going to call this compression force model. And we're going to use the same approach that we have in the past on our other models, which is we're going to take the approach of building this from the standpoint of it being for the use of someone else. In other words, as we build this, we're not going to think about how would I use this? We would think about how someone else might use this and how someone else might perceive it if they were to look at it for the first time. So we want to build it to be as intuitive as possible, so someone else looking at it is going to understand how it works, what it does, and be able to get their way through it pretty easily. And if they were to guess, they'd be more likely to guess right than wrong. So we'll start off by laying out our labels, and I always find that a really good way to do this. And once again, I like to take the approach of organizing the inputs in one area of the spreadsheet and the outputs in another area of the spreadsheet. So it makes it very clear where we put data into and where we get the data out of. I'm going to start by labeling my input values, and for this one I'll call it input values. Resize my column so that it fits. And I'm going to go ahead and use my paint bucket tool to give it a little bit of a fill color. I'll use the bold button to bold it a little bit. And now I'll go ahead and start to list my labels for my input values that we'll be entering in. I'm going to use the space bar just to get a little indent on each one of these, just for a little visual appearance. So for the very first one, it'll be our load weight. So this will be the load weight of the object being lifted. Next will come the body weight of the individual doing the lifting. Next will be the horizontal distance, and that's the distance of the hands from the low back. And then finally, we'll have our values in here for back orientation. I'm just going to call this back orientation, and this will be the cosine theta. Once that's done, we can move over and start labeling our output values. And why don't we just call this calculations? Sounds a little bit more friendly than output values. Once again, we'll use the paint bucket, give it a little fill color, a little bolding. Now for this one, actually I don't think I'm going to indent. What I'm going to do is this. I'm going to go ahead and type this out, formula A, and give it a little colon, and I'm going to then write justified in the cell. Hit the enter key. Once it's entered, I can use my write justify button. Now if we want to get fancy here, we can actually use our autofill tool, copy this down a couple more rows, and then just change A to B and A to C. And we very quickly get to build our labels that way. Okay, our last one will be our compression force. And we'll do the same thing with this. We'll write justify it. And Excel actually should be smart enough to notice that you've already write justified things above it, so it's going to assume this needs to be write justified as well. Okay, once that's complete, we're ready now to go on to our next step. And that will be to take a look at our input values. Now, before we put some values into this, we're going to want to do a little bit of data validation. And in this particular case, we want to make sure that these values are entered correctly, that someone doesn't make an error as they're inputting them. So, and also we want to make sure that they're interpreted correctly. So when someone sees load weight, they know what that means exactly. Now, it seems like it's pretty obvious. Load weight must mean the weight of the load, but in what unit of measurement? Are we talking pounds or kilos? So that could be open to interpretation. And what format? Should it be pounds and ounces? Should it be decimals? So there are different ways that this could be entered conceivably. Now, in our case, it's going to be in pounds, and we're going to keep it kind of simple. We'll make it decimals, so that this, if there is if it's more than an even number, we can just deal with it with a decimal place. So to make sure that there's a proper input message, we will use the data validation tools. So we'll start by selecting B3. We'll go up to Data and select Data Validation. And under Data Validation, our input message will be load weight. So make the input message, I'm sorry, the title of the input message the same as the label, load weight. And the input message will be enter weight being lifted in pounds. Now there's a possibility somebody might mess up and enter something that's way too heavy, and this model does have its limitations, and I'm not going to adhere to them strictly because this isn't a biomechanics class, but we'll create a couple of our own here, again for purposes of exploring some of the Excel functionality in terms of how we might accomplish this. So in this case, one of the limitations might be this. I don't think we should have somebody enter a load weight that exceeds their own body weight. At that point, I'm going to venture to guess that the model may not be entirely accurate. So under Settings, I'm going to specify what I'm willing to allow. I'll set my allow option to whole number. Actually, we can set this for decimal. We can allow someone to enter a decimal if they'd like. And the value will be a minimum of 0. So they can't enter a negative number. And the maximum will be the body weight. Now, we don't know what the body weight is because that's a variable. They can enter whatever they want, but we know where it'll be located. So the body weight for the maximum will be B4. And we can just point and click at B4 and let it fill in our box for us. Once that's done, our next step will be to create the error message that'll occur, that'll be presented if someone enters an inappropriate load weight. So we'll go ahead and click on the Error Alert tab. And as a reminder, we have 3 options. We have a stop message, a warning message, and an information message. The stop message does not let them proceed. That's it. They cannot enter that number no matter how badly they really want to. The warning will allow them to enter it, but it'll give them kind of a stern warning that you shouldn't do this. The information box doesn't really prevent them from doing anything. It just has an OK button and a little message saying whatever you want it to say. For our purposes, let's do a warning on this one. So we'll go ahead and select the warning, and for the title we'll say invalid load weight. And the error message will be load weight cannot be negative and should not exceed body weight. Once you've typed that up, we can go ahead and click OK. Okay, once you've assigned it, clicking in the cell should produce the input message. Clicking off of the cell makes it go away. Now, incidentally, when you click on the cell and the input message appears, if that message is in your way, you can actually move it and reposition it. And all you have to do is click on the message, and then you can see that you can actually drag it out of the way to a new location. So if you're finding that they're getting into your way, just click and drag them and move them away somewhere there where it's a little bit more convenient. Now we're ready to do our body weight. So we'll click on down on the body weight cell, and here we'll go ahead and do another data validation test. So we're going to go ahead and select data validation. We'll start with the input message, and our title of our input message will be body weight, and the input message will be enter the body weight in pounds. And I think that should be pretty self-explanatory. Now for the settings, let's go ahead and actually set some limitations on this one as well. Now in this case, there is a practical limitation. I believe this model is accurate up to a certain body weight, and it's probably somewhere in the vicinity of about 300 pounds. So what we're going to do is we're going to, under our allow section, we'll allow a whole number, and the minimum we'll use here is, let's do about 100 pounds. And our maximum, we'll make that 300. Normally I don't like to hard code values like this, but I think in this case it should work out okay. Whenever possible, it's better to actually enter the values into the spreadsheet and then just reference them here. That way if you find yourself needing to change them, it's a matter of changing the configuration options in the spreadsheet itself. Next, we go to the Error Alert tab. And for this one, let's give it a hard stop as our style, as opposed to the other ones. Title will be Invalid Body Weight. Sounds like a horrible thing to say to somebody. You have an invalid body weight. And the error message will be body weight must be 100 pounds or greater and cannot exceed 300 pounds. Once we have that, go ahead and click OK. Your label should appear. And now we're ready for the horizontal distance. So for the horizontal distance, we'll go ahead and create an input message. I don't think we need to worry about screening or testing the value, although we could. But as far as the input message, I think you could definitely use some explanation. So we're going to say enter the distance from the load in hands to the low back. And I'm going to just make one modification. This should actually say horizontal distance. So make one little change there. So take a look at that. Make sure you have it entered in. Enter the horizontal distance from the load in hands to the low back. And give that one an OK once you're done. Now we're ready for the back orientation. Now for this one, we're going to get a little bit fancy. Whenever you have an input area where we're selecting, or where a person is entering numbers, you pretty much have to let them just enter a number into the cell and just type whatever that number is going to be. And then you have that ability to test to see whether the number is one that you consider to be reasonable. And that's what we've done with the load weight and the body weight. On the back orientation, though, we actually just have fixed options to select from. And what we're going to do, rather than having the user type that into the cell, we're going to let them select from a pull-down list. So we're going to create a little pull-down list that they're going to use to select from. Now the list itself needs to go somewhere off in an area of the spreadsheet that's not necessarily visible, because we don't really want to confuse people thinking that they need to do anything with that or they have any control over it. I'm going to put this out here in column H, and when I zoom into my spreadsheet, column H will no longer be visible. So when I'm kind of close in like that, column H goes away. So I think that'll probably be a good area. So I'm going to start with a little column heading here. Column heading will be cosine theta. And then I'm going to go ahead and enter the values that are possible. Okay, the first value is 0. And going over to our sheet here, we can see the remaining values. They're 0.38, 0.72, 0.96, and 1.0. So we have 0, 0.38, 0.76, 0.92, 1.0. I got those right? I did. And we can be consistent with the formatting on the decimals by making everything set to two decimal places. So once you've entered those in, go ahead and select them. Going to the Home tab on the ribbon bar, quickest, easiest way to do this is to use one of the predefined formats. It's already set for 2 decimal places. The one I like to use is this comma style, and you find it right here under the style pull down selector. It's this button right there with the comma on it, and as soon as you click that, it's going to go ahead and format everything for 2 decimal places. Now notice that the 0 goes away and gets replaced with the dash. That's just the style that it uses. It means that there's a 0 there. It just doesn't show it. It shows a dash instead. If we didn't want to do that, we could switch this over to number, and that will automatically display 2 decimal places as well. So either one of those is fine. The only difference is whether or not the 0 appears. Now we've created our list of values. We're ready to create our pull down list. So on B6, we're going to go to data on the data tab again. Then we're going to go to data validation once again. We do this in exactly the same place. And let's give it an input message so it's clear exactly what it is that we're going to be doing here. And this will be back orientation. And what we're going to do here is we're going to provide a little explanation for what these values actually mean. So we'll say enter value corresponding to the orientation of the back. And then we'll enter the values. So 0 equals horizontal, meaning the person is standing up straight. 0.38 is a 1/4 bend in the back. So if you picture yourself standing up straight and then you just bend over a little bit, about 1/4 of the way down, that would be a 0.38. 0.76 corresponds to a 1/2 bend, so you're half the way towards staring at the floor. 0.92 is a 3/4 bend. And then finally a 1.0 is vertical, meaning you're staring at the floor. You're basically bent over and your face is parallel with the floor. And I totally goofed this up as I'm looking at it. 0 should be vertical, not horizontal. So hopefully you can all make this correction. So 1.0 should be horizontal. when your torso is horizontal, you're staring at the floor. When you're vertical, you're staring straight ahead. Take a moment, make sure that your values are exactly the same as mine, and we'll continue. Once you have everything typed in and everything matches up, we're going to go to the Settings tab. And on the Settings tab, under Allow, we'll click this down. And what we're going to do now is we're going to select List as to what we're willing to allow. And there's a checkbox here for In-Cell Drop-Down, and we're going to keep that checked. If it's not checked, make sure to check it, because that's how this is going to work. The source box, if you click your cursor inside of that source box, so you've got your flashing cursor in there, what we can do is to come over here and select the cells containing those values. So you're going to select from H2 down to H6. As soon as you do that, it'll fill in the values in the box. You may notice that it puts those dollar signs in there, which we all now know mean it's absolute cell reference. So it does this because if we copy this cell elsewhere and we copy that data validation test, it wants to make sure to always refer to the same place for the list values. Otherwise, if they're relative and we copy that someplace else, we run the risk of it pointing to the wrong cell, and we don't want that to happen. So it automatically puts the dollar signs in there, kind of anticipates that. Once you have that, go ahead and click OK. Now the input message should describe to you exactly what this thing is going to do. And you'll see you have a little drop down which allows you now to select one of the values. So the user will be able to just go in here, click on and select, and they have their little box here that gives them the instructions for what needs to go in there. Okay, so with that, we now have the data validation tests completed for our inputs. Let's go ahead and put some input values in, and in the process we'll test our data validation conditions. So we'll start with the load weight. Actually, we'll start with the body weight, because the body weights, or the load weight will be contingent on the body weight. So for the body weight, let's try a value that we know shouldn't work, 99 pounds. That should be below our minimum. And sure enough, it comes back and says body weight must be 100 pounds or greater, cannot exceed 3 pounds. Okay, should have been 300 pounds. And it gives you the option to retry it, meaning you can enter another one in. If you try 301 pounds, you should get exactly the same error message. Hopefully yours is correct, although mine is not quite correct. But I should be able to enter anything in between. So let's try 150 pounds, and sure enough, that goes in properly. Now the load weight, remember, should not exceed the body weight. So if I enter 151 pounds, I should get an error message here. Now remember, on this one we did a warning error, or a warning message, not a stop message. So notice that this one's a little bit different. It's not it's actually letting me continue if I want. I can hit yes to continue or no not to continue. So I'm going to type no, and let's enter a little bit more reasonable number for our purposes. Let's enter 40 pounds. The horizontal distance, okay, remember this is in inches, and I actually forgot to enter that into the input message. That should have said enter horizontal distance in inches from load to hands to blow back. But we'll go ahead and enter a value to get started. Let's try about 20 inches. That sounds like it's probably reasonable. And the back orientation for this one, let's start with a 1/4 bend. So someone who's just bent over a little bit as they're picking up this object. So now we have some reasonable values in here. We have something to work with. We can go ahead and begin building our formulas. I've gone ahead and put the formulas up on the screen for you for convenience, so you have them to look at. Now our next step will be to build each one of these formulas inside of Excel in the appropriate cells. So we have our 4 formulas. We have A, B, C, and then the final compression force formula, which adds the 3 together. And from the labels you can see where they all go in the spreadsheet. So your task right now is to go ahead and take a stab at building these 4 formulas inside of Excel. I will go through each one of them and show you how I do it after you're done, but I'm going to caution you that it's really important that you give this a try first. If you just watch me do it and then just mimic what I'm doing, you really won't learn very much from that. If this is something where you're looking at it right now and you're thinking to yourself, I'm not really sure what I know what I'm supposed to do, I can tell you right now that the best thing you can do is to struggle with it a little bit. Go ahead and give it a try and just struggle with it a little bit. And what I'd say is I'd like you to build formulas. They don't necessarily have to be right, but I want you to try it so that you've done something and you've gone through a thought process and you've created something. You might be right on and you might be totally off base. When I go through and I show you how I do it, you'll be able to compare the two and see where you messed up, if you messed up. But that will be a much better learning experience for you. I can promise you that if you go through that process and you struggle a bit and you're able to reconcile it afterward, you'll be much more likely to remember how to do it right the next time around, and it will stick with you. If you just copy me doing it, it won't, and I can promise you. The other thing I will tell you is that there will be a question on the final virtually identical to what you're seeing here, but different formulas. So you'll have a situation where you've got a spreadsheet laid out and some formula logic provided to you, and then it would be your job to create the Excel formula syntax inside of Excel. So you need to be able to do this for the final. This is a no-risk environment. If you mess it up, the worst case scenario is you're going to learn something from the process. It'll be a good thing. I really don't mind if you mess it up right now. What I do mind is if you don't try. That's a much bigger problem. I'm going to go ahead and leave this on the screen for a few seconds, and then when we come back I will step through each one of the formulas and you can compare your formula to my formula and see if there's a problem. So with that, go ahead and give it a shot. My suggestion is you go ahead and pause the video at this point if you're not done, and then go ahead and resume it when you have your formulas in place. Okay, we're now back to our spreadsheet and ready to begin building our formulas. Now, I went ahead and I put a little box down here with the actual formula logic just so we can see it on the screen at the same time that I'm typing it up. This is not part of your spreadsheet. So again, this little box down here with the formulas is not part of the spreadsheet. I just placed it there so that we have ready access to the formula logic as we build the syntax. So if you don't see it on your screen, good. You shouldn't have it on your screen. Now, I'm going to go ahead and start by building formula A. Now formula A, the logic says it should be 3 times the body weight times the cosine. So I'm going to start with my equal sign, the number 3. Now I know I've been telling you guys never ever ever put numeric values into formulas. Well, this is an exception, and the reason it's an exception is because this is a constant in the formula. It never changes. If it's not 3, it's wrong. It has to be 3. So it is part of the formula. We have to keep it that way. There's no reason to capture that in the spreadsheet as a cell. We can just type it directly into the formula this way. Okay, we're going to use our multiplication symbol, which is the asterisk. The body weight is located in cell B4, so I'm going to point and click at cell B4. One more asterisk, and then we're going to multiply that by the cosine, and that's our back orientation value down here. So that first formula should be 3 times B4 times B6. And that will essentially give us the logic for 3 times the body weight times the cosine. Now, when I'm done with that, I'm going to do exactly one thing and one thing only, and that will be to hit the Enter key. I'm not going to click anywhere. I'm not going to hit the arrows. I'm just going to hit the Enter key, and that's it. Okay, my result is 171. So make sure that you have that same result. That's what you should have in order for it to be right. Our next formula is 0.5, so another constant in a formula, times the load weight times the horizontal distance from back. That's what the HB stands for. We'll start with our equal sign, 0.5, asterisk for multiplication. The load weight is located in cell B3, so we will point and click at our B3. One more asterisk, and this will be times the horizontal distance, which is located in cell B5. So I'll point and click at cell B5. Hit the enter key, and you should have a result of 400 if you did it right. If you don't have 400, or if you don't have 171, go back and take a look at my formula as I had it displayed there when I completed it, compare it to yours, and rather than just changing it to be right, what I'd really like you to do is to think through the logic of why you built yours the way you did. What were you thinking? And I don't mean that in any sort of derogatory way, what were you thinking? I mean it seriously. Figure out what were you thinking? How did your logic take you to that place? And then compare it to mine and see if you can find a pattern to maybe how you're looking at this. And that's really the best way to do it. You have to sort of be able to explain why you're thinking a certain way before you can change your thought processes sometimes. Okay, formula C is kind of the ugly one. And that's because we got a bunch of stuff going on in here. We got multiplication, division, and addition all happening in the same formula. So for this one to work, we're going to need a couple of sets of parentheses. So we'll start with our equal sign, and we will be multiplying by 0.8. So we're going to start with 0.8 times. Now, again, we're going to need two sets of parentheses here because we have to take the body weight and divide it by 2. That has to happen first. Then we have to add the load weight to that result. So we put that inside of parentheses, and then that whole mess gets multiplied by 0.8. So this is why we have the two sets of parentheses, is to set our order of operation. So I'm going to open two sets of parentheses. The body weight is located in cell B4. So I'm going to give B4 a point and click. Divided by 2. Okay, so I've got my body weight divided by 2 now. That's B4 divided by 2. Now I'm going to add the load weight to that. So that's going to be plus B3. And now I can close that second set of parentheses. By the way, notice that when I do that, and when you do that, when you hit that last parenthesis, the opposing parenthesis that's still open will flash. So it'll show you how it's pairing up the parentheses. It's kind of cool. Okay, take a look at your formula. Take a look at my formula. The result should be 92 as formula C. So make sure you have a result of 92 in formula C. Once again, if you don't, then it means that somewhere along the line you've got a difference either in the input values or in the formula logic. Go back to my formulas when they were exposed and compare them to yours. Now the compression force formula is a really easy one. This one is just going to be these three things added together. So I'm going to start with my equal sign, and this will just be point and click E3 plus E4 point and click plus E5 point and click. So this is what that compression force formula should look like. Press the enter key, and you should end up with compression force of 663. If you have something other than 663, compare each one of your formulas, A, B, and C, to mine. If one of them is different, the two things that can possibly cause that, one would be a difference in the input values, and the other would be a difference in the formula syntax. So that's your process that you'll use to troubleshoot and see where you went wrong. Okay, now I'm going to go ahead and get rid of this box here with the formulas. We really don't need that anymore, and that was just there to help this illustration along. Now let's do a little bit of testing with our formulas and see what kind of results we get when we do some what-if analysis. Now, if I take the load weight, now by the way, actually, when we look at this, the compression force comes out to 663. As it stands, someone else using the spreadsheet would have absolutely no idea whatsoever what that means. Is that good? Is it bad? What the heck does it mean? And what it is actually, it's the result, it's the amount of compression force expressed in pounds per square inch. Okay, that's actually what the output is. And we can go ahead and actually, in the neighboring cell here, go ahead and enter PSI for pounds per square inch. And another thing we can also do is attach a comment to that cell that describes what exactly the output means. So a comment is kind of a nifty way in Excel to help document a spreadsheet. You can use comments pretty much the same way you would use them in Microsoft Word. It's a way to just attach a comment to a spreadsheet cell that you can go back to it later and read or revise, or just use it as a reminder of why you created a formula a certain way. To attach a comment, we're going to select the cell, right-click the cell, and select the option to insert comment. Now, the comment box will actually have your login name listed. On this particular computer, my login name is listed as E. I know it's really really descriptive, but that's what it is. I'm E. But depending what you've logged in as, it'll normally show that. So someone using the spreadsheet can actually see who made the comment. Now, my comment is going to be this: compression force is expressed in pounds per square inch exerted on the lower vertebra. Okay, so now someone using the spreadsheet will be able to see exactly what the definition is of that. Now, to make the comment go away, just click off of the cell, and normally the comment should go away, but it appears that right now this one is set to stay on. If it stays on, you can right-click and click the option that says Hide Comment. Normally the way a comment works by default, not sure why mine is working differently, when you hover over the cell, the comment will appear. And when you hover off the cell, it disappears. It's a little bit like the input message, but on the input message you actually have to click into the cell in order for it to appear. On a comment, you just have to hover over the cell. Okay? And that's basically how your comments work. Now, if you're thinking that 663 pounds per square inch seems like an awful lot of force to exert on your spine, yeah, you're kind of right. It does seem like a lot of force. The reality is that your spine actually can handle quite a bit. That's not an unreasonable amount of compression force, and probably not one likely to cause injury in most cases. Normally the upper limit, I believe, is considered to be somewhere upwards of about 1200 psi, so about double that actually. But at this point, this is actually, I think, normally considered to be a fairly normal value. So we wouldn't worry really too much about 663. Let's do a little bit of just validation testing. And one of the things I like to do with a model is to go in and just vary some of the numbers and see if the results appear to vary the way I would expect them to. So we'll start with the load weight. Now, if I take the load weight and increase it, my expectation is that the compression force would also increase. Okay, the heavier the object you're lifting, the more force is likely to be exerted on your spine, I would think, just logically. So we'll go ahead and I'm going to take that from 40 to 50, hit enter, and sure enough, you see that the compression force value actually increases up to 771. It increases more by just the 10 pounds that I entered here. Okay, there's a leverage effect that occurs, and this is also pounds per square inch, which is a little different. So that seems to make sense. Load weight increases, compression force increases. Our next value is the body weight. Now the body weight's kind of an interesting one because we can think of this a couple of different ways in terms of what effect it might have. But let's go ahead and take the body weight and take it from 150 up to 200, and let's see what that does to the compression force. Now when I enter the 200, take it up to 200, my compression force jumps up to 848. So more body weight increases compression force. And that's actually very realistic. The way to think about it is that your spine is not just supporting the weight that you're lifting, but it's also supporting your own body weight. And in fact, that one formula that had body weight divided by 2, that's what it was doing. It was saying roughly half your body weight is supported by your spine. So the heavier someone is, the more compression force is naturally exerted on their spine, regardless of whether or not they're lifting anything. Next, we'll alter the horizontal distance. So this is the distance away from your lower back that your hands are, which are holding the load weight. And we'll try taking it from 20 inches out a little bit. We'll increase that to 22 inches. Our compression force is starting out at 848, and as we increase it, we see it jumps up to 898. So it actually picked up about 50 pounds per square inch in compression force just by moving your hands out 2 inches. And the way to think about this is as your hands are moving away from your body and that load weight is moving away from your center of gravity, you're essentially getting pulled forward by that additional weight. In this case, we have a 50-pound weight that you're moving further away from your body. Your back muscles are pushing against the base of your spine to keep you upright, to keep you from toppling over, and that's producing that additional compression force. So that horizontal distance does make a difference, and we can kind of prove that here, and we can also use this to validate that, okay, yes, the model seems to be responding the way we would expect it to. Now finally, let's take the back orientation and let's see what happens when we alter that one a bit. So I'm going to take this from 0.38, which is about a 1/4 bend. So you're bent over about 1/4 of the way. And we'll take this up to 0.76, which is about halfway bent over. And when we do that, we see we actually get a pretty sizable jump here in the compression force. And once again, this one kind of makes sense. When you're standing up straight and your back is straight and you're vertical, all of your vertebrae are essentially kind of stacked on top of one another. So they're more or less equally absorbing that compression, that weight that's being exerted on them. But when you bend over, what happens is that the lower part of your back now becomes sort of a fulcrum, and there's a leverage effect that occurs there. Once again, the weight is pulling you forward, and because your vertebrae are kind of not stacked now, but they're kind of at an angle, your back muscles have to work at keeping you from toppling over, so the majority of the weight now gets exerted on the lower part of your back. And this is one of the reasons people who lift incorrectly very often end up with chronic back pain. It's from those types of repetitive injuries. So as we go through this, we can see that the results seem to be pretty much what we would expect them to be. Relatively predictable, and I think we can say that our model is valid as it stands, and that we can go ahead and assume that these numbers are going to be relatively correct for our purposes. So our next step now will be to improve our model a little bit. We've got kind of a nifty model here. We've done a little bit of analysis with it. We've done a little bit of validation with it. So now what we'll do is we'll maybe include some improvements with our model, and in doing so we'll explore some additional functionality. Now we're ready to add some additional functionality to our spreadsheet. Before we do this, let's modify our input values a little bit so that we're all using the same numbers. We're going to drop the load weight down to let's do about 35 pounds. Body weight, we'll make that about 150. Horizontal distance we'll keep the same. And the back orientation, we can drop that down to 0.38. So we have a reasonable result here of 644 psi. Now, one of the things that we can do with Excel is we can add some interactivity in that we can use visualization to help indicate when numbers maybe are approaching a certain level that we might have some concern about. And in this particular case, if we make the assumption that the compression force value is associated with the risk of back injury, one of the things that we can do is to change the appearance of that cell based upon the presence of risk. So before we start this, what we'll do is we'll create a little section here under our input values where we will enter our values that we believe are associated with moderate and high risk. So let's assume that 1,000 psi, we're going to consider that to be elevated risk, and at about 1,250 psi, we're going to consider that to be high risk. So we're going to create a section here under input values, and we will call this risk factors. And I'm going to give it a little underline. Now, one thing that I neglected to do earlier on, was to change our font colors on our input values so that we make them blue and indicate that these are actually input values. So this is a really good time to do that. I'm going to go ahead and select blue, and it always takes me a couple of attempts because I am horribly colorblind and probably about the most colorblind person you'll ever meet. So I have to just try each of the values and hover over them until I get the color that I think I want. So your input value should now be in blue, indicating that these are actually inputs that are okay to type over, as opposed to our calculations, which are never okay to type over. Let's go to the risk factors, and we'll enter our first one. Let's call this first one elevated risk. And for this one, we'll go ahead and enter 1,000 psi. Let's make the assumption that at 1,000 psi, we're at elevated risk. And next, we'll set one up for high risk. And this one we'll set at 1,250. Now that we have both of these, we'll select them. And I'm going to go ahead and assign them a comma style. Now the comma style just introduces the comma as the thousands separator, just makes it a little easier to see. We really don't need decimal places here, so we will use the decrease decimals button to get rid of them. Each time you click it, it will remove one decimal place. Once I'm done with that, I can go on to my next step. Now for this one, we are going to create something called conditional formatting. Conditional formatting is kind of what it sounds like. It lets you establish a condition, and based upon that condition you can format a cell a certain way. So essentially what we'll do is we'll change the appearance of this compression force cell based upon the value that's contained within it. We'll start by selecting cell E7. We're going to go to, on the Home tab, we're going to go to the Conditional Formatting button. And as you can see, there are a bunch of different conditional formatting options. You can do some really, really fun stuff with conditional formatting. We're going to pick the Highlight Cells rule, and we're going to select the first one, which is the greater than rule. Now, what the rule wants to know is essentially this. It's going to let you establish that if a value is greater than some amount, then you can change the color, the background color and the font color of that cell. In this case, the value that we're looking for, or the cutoff, the thing that we're comparing it to, is going to be either B9 or B9 or B10. Well, for this one, we'll do B9 first. So what we're going to say is if it's greater than B9, then let's use the yellow fill with dark yellow text. So if it's greater than B9, we're going to give it a yellow color. Okay, and that's again going to be our elevated risk format. Okay, once you've established that, go ahead and click the OK button. Now what we're ready to do is to add our next rule, which will be for a high risk. We're going to go once again to conditional formatting, highlight cells rules, greater than, okay, and logically, after you've done this once, it should kind of make sense what you're doing. You're basically saying highlight the cell that's greater than a certain amount, if the cell is greater than a certain amount. Okay, this time the amount that we're looking for is 1250, which is in cell B10. We're not going to type in 1250 because that number could change. We want to give the user the ability to change those inputs. And for this one, this is our high risk level. We'll make this one red. So we'll make it a light red fill with a dark red text. So that should hopefully stand out pretty well. Go ahead and click OK. All right, now nothing will visually change at this point on the spreadsheet because right now our compression force value is 644, which is lower than either one of these. So there's really nothing for it to do. Now to force it to go up over 1,000, let's take the load weight and let's crank it way the heck up to maybe 150 pounds. And you can see that that takes the compression force up to 2,000 psi, which is above the high risk threshold, and it turns to red. So now we have a red on red. Now let's take the load weight down a little bit to try to get it between 1,000 and 1,250 to see what happens. So I'm going to try taking it down to 100 pounds first. Not quite enough. Let's try taking it down to 75 pounds, and there we go. At 75 pounds load weight, the compression force is 1,016 pounds, and that's our elevated risk level because it's over 1,000. And now we're getting the yellow background color. So you can see how the conditional formatting works. As the value in the cell changes, the color and the format of the cell changes. And we could have a whole bunch of these if we wanted to. So this is actually a really neat technique we can use with spreadsheets that are designed to be interactive, where people are plugging numbers in and using the results. So again, it helps communicate what they're looking at. Now, also at this point, we can see here too that compression force cell. It would probably be a good idea to format that as a comma format as well, and then get rid of those extra decimal places. Again, just makes it a little bit easier to read. Okay, for this next addition to our spreadsheet, we're going to use a logic function. This is also called an if-then-else function. And our objective here is to actually provide some verbal feedback to the user of the spreadsheet. We'll do that by creating a series of labels. So based upon what the value is in that compression force cell, we're going to return either a label that says OK, or elevated risk, or high risk. So before we start, let's resynchronize our input values and make sure we're using the same values. I'm going to take the load weight down to 35 pounds once again. Keep the body weight at 150, horizontal distance at 22, back orientation at 38. That should give us a compression force of 644 psi. Now, our formula is going to go down here below the compression force formula, and I'm going to give this a little label. I'm going to call this status, colon. I'm going to have it right justified in my cell, so go ahead and enter that on cell D9 and make sure it is right justified. If it's not, the right justification button is right up here on the ribbon bar. Now the formula is going to go alongside here in cell E9. Now the label that we're going to create is probably going to be a little bit wider than the column width, so we'll probably end up having to widen it a bit, but we'll cross that bridge when we come to it. Now, in order for this to work, what we're going to have to do is the following. We have to compare the compression force number to this number and to this number to see whether it exceeds either the value in B9 or the value in B10. And if it does, we need to return one of these values. If it doesn't, it means it's below 1000, and it's okay. We're not worried about it if it's below 1000 because that isn't considered elevated risk by our standard. So to do this, we are going to use something called an if function. So as you recall, we discussed functions in class this past week, and functions are like little self-contained computer programs within a computer program. The if function is a function that does a very specific task. It evaluates a condition, and then based on the result, based on whether that condition turns out to be true or false, whether the condition is in effect or is not in effect, however you want to look at it, it will return one of two possible outcomes. So if you think about it, a condition is a true or false statement. When you set a condition, that condition either can be in effect or not in effect. In our example of our spreadsheet, the condition is whether or not the compression force value is greater than the elevated risk value of 1000. And there's only two possibilities there. It's either greater or it's not greater. There's no other possibility. If the possibility turns out to be true, then the if function will return whatever it is that we specify should be returned. Otherwise, it'll return something else to the cell. So this is how an if then else function works. It's called the if function. In programming, it's usually called an if then else statement, and that's simply a programming technique where you specify a conditioning. You say if this condition exists, then do this, do something, else do something else. Hence the term if then else, and you'll see that stated. Now the syntax of the function looks like this. Here are the arguments that we use. We start with the first argument, which is the condition that is to be evaluated. Now remember, we separate arguments with commas. So if that condition turns out to be true, we return the result if true. That result can be anything. It can be a number, it can be a formula, it could be a cell reference, it can be a label. It can be literally anything we want it to be. The third argument, is the result if the condition turns out to be false. So in other words, if that condition is not in existence, then here's what we want to return to the cell if that's the case. So here are a couple of examples just to show you some ways that the if then else function could be used. In this first one, if A2 equals A3, that's our condition. It's comparing A2 to A3. The comma then breaks up in our next condition, our next argument, and it says return C7 divided by 100 into the cell. So if A2 really is equal to A3, put C7 divided by 100 into the cell. Otherwise, which is the second comma, that's the else, return D7 divided by 100 to the cell. In the next example, we have a different condition. If D120, now the greater than and the equal sign together means greater than or equal to. So if D120 is greater than or equal to 5, return 5 or more to the cell. Now, whenever we return a label to a cell using an if-then-else function, and actually using most functions that work with labels, require that the label be contained within quotation marks. So in this case, our label is 5 or more. We would put that inside of quotation marks. And that's how the function knows that we're talking about a label and not a cell reference or something else that it has to try to decipher. So if D20 is greater than or equal to 5, return 5 or more to the cell. Otherwise, that's the second comma, return less than 5 as the label to go into the cell. Okay, so 3 arguments: the condition, the result to return to the cell if the condition is true, and finally, the result to return to the cell if the condition is false. Okay. With that, we'll go ahead and set up our function here within our formula. Within our spreadsheet. Now, we created this label called status, and our result is going to go right alongside. So what we want here is a little message that says status, and then right alongside, it's going to indicate either elevated risk, high risk, or we'll just maybe return OK as our default value if neither of those apply. We'll begin by creating our if function. Now, I'm going to do this in 2 stages. I'm going to create the function, but I'm only going to create it part way, and you'll see why here shortly. So this is going to call for a nested function. We can actually put an if statement inside of an if statement, which is what we're ultimately going to do. But we'll start off and keep it kind of simple, just so we can see how this builds. So I'm going to start with if. I'll open my parentheses. Now it's asking me for my logical test, and we can see down below here where it's prompting me for the arguments. The logical test will be this: if E7 is greater than or equal to E9, then, and that comma, we can sort of interpret that as being like the word then. What do we want to put into the cell? Well, I'd like to put the words elevated risk into the cell. Now, I could either type this as a label inside of quotation marks, or since it's already in a cell, I can just point and click at it. That's all I have to do. So if E7 is greater than B9, then return A9. Now, I'm going to end it right here. I'm actually going to end it a little bit prematurely, but that's okay. Now, in this case, it's saying it's returning the word false. And the reason is because 644 is less than 1,000. So there's really nothing to put in there. I didn't give it an else. I didn't tell it what to do if that wasn't the case. I'm going to go back in here to edit it now. And I'm going to change this slightly. I'm going to say if E7 is greater than or equal to B9, then return the value in cell A9, which are the words elevated risk, else return the label OK. I'm going to put that inside of quotation marks. So double check your formula, make sure it looks like mine. We'll hit the enter key, and it should come back and say OK. And the reason is because 644 is less than 1,000. So we're okay. We're below that elevated risk threshold. Now let's test this to make sure it actually works properly. I'm going to take the load weight, and let's just artificially increase it so that we can get a compression force of over 1,000 psi. So I'm going to take my load weight up to a value of 100. I'll hit enter, and you can see that the status now changes to elevated risk. Okay, and that's because we exceeded that 1,000 threshold. Okay, so this is the if statement, or the if function in action. You can see what it's doing here. It's evaluating the relationship between this cell and this cell. And based on their relationship, it's either returning the word OK or it's returning the words elevated risk. Now, we want to make this just a little bit more sophisticated than that, because I have this third option. I have this high risk option. If it goes over 1250, I'd like it to say elevated risk. I'm sorry, high risk. Now, to rework our formula, we're actually going to start by deleting the existing formula, the one with our if statement that we worked on. I know you worked hard for it, but we'll do it again. This gives us a little bit of repetition, so we do this more than just one time. And I think maybe helps make it a little bit easier to understand how we're building off of the original function. So I'm going to start with my function again. So we're starting with my if function. I'm doing this in all capitals. It's really not necessary. I just do that to make it a little bit easier to see visually. And when we're doing multiple levels like this, because we're doing nested if statements or if functions, it's usually best to start at the high end of the range and work your way down. So we're going to start with our highest one first. And what we're going to do is we're going to compare E7 to see if it's greater than or equal to B10. Okay, so that's our first condition. We want to know, is this in the high risk group or not? Okay, so is E7 greater than or equal to B10? The comma, we can kind of think of it like the word then. So if E7 is greater than or equal to B10, then what? Well, in that case, I want to return these words here, this label in A10, which says high risk. So if E7 is greater than or equal to B10, then put the label in A10 into the cell. Else. Now, we can interpret the second comma as being like the word else. Well, if it's not greater than B10, not greater than or equal to B10, then what? Well, then I want to know, well, is it greater than or equal to B9, which is the elevated risk tier? So I'm going to start another if function. Okay, and this is where, if you look at this thing, it can be a little tricky the first time, but if you think through the logic, it's really not. So we're saying if E7 is greater than or equal to B10, then put the high risk label into the cell. Else, well, let's take a look to see if it's greater than or equal to the value in B9. So once again, we're going to just do another condition here. If E7 greater than or equal to B9, well, then what? Well, if it's greater than or equal to B9, then we want to put the label in A9 into the cell. We want to return the words elevated risk into the cell. Else what? Well, what if neither one of those things applies? What if it's not greater than 1250 and it's not greater than 1000? Then what? Well, in that case, we can just return the word okay, because that means it has to be less than 1000, and that's our okay range. So I'm going to end with else okay. Now, I'm saying else, but really that's the comma. The comma kind of means the word else here. So our final argument will be the word okay. Again, it has to be in quotation marks, and you need to have the beginning and the ending quotation marks for this to work. Otherwise, it won't work. It won't know that you're typing a label. It'll think it's some sort of a formula or a cell reference. Now that we have that, we can go ahead and close our if function, our second if function, and then we can close our first if function. So we need two closing parentheses here, one for each one of those functions that we started. Now take a quick look at your function. Make sure it looks like mine. It's big and it's messy, but trust me, they can get much bigger and messier than this one. So this isn't that bad, really. We're only going down 2 levels. I've seen these go down a dozen levels sometimes. Now that you've confirmed it, go ahead and hit the Enter key. Now let's test it to make sure it's working properly. So the first quick test is to look at the existing value. It says high risk. For it to be high risk, this number needs to be greater than the high risk threshold, and it is. 1411 is greater than 1250. So this is appropriate. Now let's take our load weight Let's reduce it down to get that compression force to calculate lower. We'll take it down to about 75. And that brings the compression force down to 1116, which is lower than 1250, but greater than 1000. And appropriately, it comes back and tells us that the status is now elevated risk. And that's reflected by the conditional formatting, which gives us that yellow format. Now, our final test will be to take that load weight and force the compression force down below 1000. So I'm going to take it down to maybe just 10 pounds, something fairly minimal. And we see that it works. The compression force drops down to 349, which is lower than 1000, and the status returns OK. So we were able to program that status cell to return the appropriate message based upon the compression force value. So this is how an if function works. So we started off keeping it very, very simple with just one condition and one return. And then we went ahead and we added a second tier to that with that final else comment, that final else result, which was the OK label. So this is a pretty good example of how if functions can work. Now, incidentally, I mentioned that they can get much longer and you can have a lot more of these nested within an if statement. And that's absolutely true, but it's not very efficient. For two nested functions like we just did, this is probably a reasonably okay way to do it. When you have a lot more than that, then it becomes really kind of problematic. And you can tell why, because when we look at this function, it's kind of messy. You have to really sit there and stare at it to figure out what it's telling you that it's going to do. Even if you're used to looking at these like I am, it takes me a minute to look at it and figure out exactly what is happening inside of this function. If you're not very experienced with them, it can take you a lot longer to figure out what the heck it's doing. Sometimes you just have to experiment to see what kind of results it returns. Well, when they get much longer, and you get 3 or 4 or 5 levels to them, instead of using nested if functions like this, a much better way to do it is with something called a lookup function. And there are specifically two kinds. There's a horizontal lookup function and a vertical lookup function. They're called HLOOKUP and VLOOKUP. And you will be using one of those in the lab assignment, which is in the Cognella active learning pages. So when you get to that, we won't be doing the if function, we will be doing a lookup function instead. It's much more efficient. Once you understand how it works, it's a lot more powerful because you can have 50 or 60 or 70 or hundreds of results, and the length of the formula doesn't change. It always stays the same. So it doesn't get nearly as messy as this one does. Okay, so at this point you should now have a working if function. If it's not working and you went through that test process that I just went through by reducing the load weight and you're not seeing it change to the correct value, go back, take a look at my function, take a look at yours, and again review the logic. Don't just mimic the keystrokes, but try to understand what the logic is behind it, because that's really kind of the important thing. You're not going to be able to build one from scratch yourself when you need to if you're just trying to rely on your memory of how I did it. It's really more important to understand the basics of how it works, what it's expecting, and the logical flow behind it. They're really not that complicated. They're honestly not once you kind of understand how they work and you've done one or two. So hopefully this gives you a push in the right direction. Okay, so with that, we actually now have the majority of our functionality behind our worksheet. The next thing we're going to do is we're going to take our worksheet and we're going to dress it up a little bit. We're going to do some formatting to make this look a little bit nicer. Not just nicer, but also a little bit more functional. So if you were going to take this worksheet and give it to somebody else to use, maybe who is not as experienced or familiar with Excel, we want to put it into a format that's not intimidating and that is fairly easy to understand. So that will be our next task. All right, we're now in the home stretch of our model, and what we're going to do next is spend a little bit of time with some formatting. So we'll basically make this look a little bit nicer from a visual standpoint, and in doing so also try to make it a little bit more usable. So as we work on some of the formats and the background colors and so forth, we'll make this look a little bit more friendly for somebody who is looking at it for the first time. So the first thing I'm going to do here will be to actually reduce the increase the size of my row 1. So I'm going to take my cursor and put it right here on this header, row header, between 1 and 2, and notice that when I do that, when I get right on that dividing line, my cursor will change shape, turns into kind of a, once again, a crossed arrow looking thingy, this time vertical. And at this point I can click, hold my button down, and I can stretch that row down and make it bigger. Go ahead and follow along with that. The next thing I'm going to do is to take my some of these cells here, and what I'd like to do is to get a title on this, and I think I'm going to be placing my title somewhere here between columns C and E. So I'm going to select all 3 of those. Now if I type in any one of those cells, the text, if it's long enough, will exceed the width of the column, and it won't necessarily line up or center where I want it to. I'd like it to center right in that general area there. So what I'm going to do is merge those 3 cells together. So by merging them together, I'll create one giant cell, which will allow me to center a label inside of that. So once I've selected cells C1 through E1, I'll go ahead and press the Home tab. And on the Home tab, right in about the middle of the ribbon bar, you'll see there's a button there that says Merge and Center, and it shows you a little example of what it will do exactly. So it's going to, in this example here, take this these 3 cells and merge them together into one giant cell, and it'll apply a center format to whatever's inside. So I'm going to go ahead and click that, and you'll see that as soon as you do that, those dividing lines, those column dividing lines, essentially go away, because now what we've done is we've turned it into one giant cell. Now at this point we can go ahead and type in a title, and I'm going to call this my back compression force calculator. After you've typed in your title, the next thing we'll do is we'll center it vertically in the cell. So right now it's centered horizontally in the cell, meaning it's right in the middle from left to right, but I'd like it to get centered vertically, so it's in the middle of this rather than at the bottom. And to do this, we're going to use the vertical alignment buttons, and they are located right above the horizontal alignment buttons. So these are the buttons that we use to left, right, and center justify. And just above that, you'll see you have these 3 other buttons, and these are essentially, they do exactly the same thing. The only thing is they do it vertically instead of horizontally. So if I click the middle one, that will then center it vertically within the cell. So now it will float up to the middle of the cell. Once we have it in the middle, we can go ahead and maybe give it a little bit nicer font. We can pick something kind of fun that may work for it. And this one is kind of your call, what you'd like to do with it. And I'm going to pick one almost kind of at random here. So I'll give you a minute to go ahead and pick one. And I'm going to increase the size on it, make it bold. And now we have a title over our model. Now, the next thing we'll do is give it a little image. We're going to throw some a graphic in there, just to, again, kind of help visually illustrate what this thing is about. And we'll do this using the Insert tab on the ribbon bar. You can go ahead and click Insert. And we'll want to start this, by the way, we'll be placing the image in this area over here. There's no need to really merge it. We could merge these two cells together, but there really isn't any need to for what we're going to do. But we'll go ahead and put the cursor in cell A1. That's approximately the location where we will want it to go, this upper left-hand corner. So we're going to click Insert tab and then Online Pictures. And we have two options here. We can pick stuff that may be on a OneDrive account, or we can do a Bing image search. So for this, let's do a Bing image search and see what we're able to find. Now we can enter a keyword that will be associated with the type of image we're looking for. I'm going to try lifting. That's the word I'm going to use, and we'll see what comes up here. I honestly don't know. And there we go. Now here are the results that we get, and I'd like to point something out here very quickly. There's a little bar down here where it says these results are tagged with a Creative Commons licenses. Review the licenses to ensure you comply. Now we've talked a lot when we discuss legal issues about the whole concept of intellectual property and copyrights. So a Creative Commons license is almost like an open source license, but it applies to images, videos, other multimedia type objects. And the idea is that they're shareable. So when you create something, when you create a photograph or an image, you own the copyright to that. You get to decide who can do what with it. And if you'd like to just share it publicly and let people use it in whatever way they'd like and to potentially redistribute it, you can use a Creative Commons license, which basically means that you're telling people this is a Creative Commons licensed image, and the idea is that they can use it for free. They're not allowed to charge money for it, but they're able to reuse it if they'd like to. And what this is telling you is that these are all Creative Commons licenses, but it's also urging you to read the license to make sure that you're in compliance with it, that you don't do anything that is going to be in violation of that license agreement. The important thing from our standpoint is that we can use these and we don't have to pay for them, and it's not going to cause a problem. So for our purposes, we can pick one of these, and it's kind of like our call. I'm going to go ahead and pick this one here because it actually kind of helps make the point. It goes right along with what our model is doing. It's essentially showing what the differences are between different types of lifting techniques by quantifying them. So I'll click on it. That checks the little box, and I can now press the Insert button. It will insert it into my spreadsheet. I'm going to zoom out of my spreadsheet, and I can do that using my little zoom tool here. Now notice this thing is way too big because it's completely obscuring the entire model. So I'll need to resize this to make it usable. Now this is a really important concept here. When resizing an image, notice you'll see that there's these little circles all the way around it, surrounding the entire perimeter of the image. And these are all places where we can click on the image and then we can stretch it. I'm going to give you one hard and fast rule to follow. Never, ever, ever click on one of the sides, top, bottom, left, or right. So never click on one of these sides, and I'll show you why. I'm going to go ahead and click on it and resize this image to make it bigger. And notice when I do that, what's happening is I am distorting the image. I'm stretching it out sideways, and I'm changing the aspect ratio of the image. Now the aspect ratio is the height to width ratio. If you change that, you will cause distortion in the image. It now looks really bad. You can even see it in the writing there, how it's getting stretched out horizontally. So that's absolutely the wrong way to do it. I'm going to click my undo button to bring it back. Now the proper way to do it is to click on one of the corners. If you click on a corner, you can then resize the image, and it will protect the aspect ratio. The aspect ratio won't change as you increase and decrease the size. It'll always be in proportion. So that would be the correct way to do it. So go ahead and grab one of the corners, resize it, and get it to where it's about the right size. Now you may need to make some changes here. You may need to resize some of the columns in your spreadsheet or that row 1 in order to make it fit and make it visually look good. So there may just be a little bit of trial and error there involved in getting it to work. But once you've got it to work, you should have something that looks reasonably acceptable. So I'll go ahead and we're going to pause here for a second and let you go ahead and get everything kind of nudged into the right position. Again, resize as necessary using one of the corners, resize the columns or the rows as necessary until everything looks like it's about in the right place and it looks fairly reasonable. Okay, back to work. If you're still working on it, go ahead and pause the video and pick it up once you're done, and then you can go ahead and continue on to the next step. So the next step for our purposes will be to provide a little bit of additional fine-tuning on the image, and we can do this actually by clicking on the image. Once the image is selected, you'll notice there's a Format tab that will appear up on the ribbon bar. If I click that Format tab, I now have some additional options available to me. I can put a border on the image if I'd like. I can give it a shadow effect. Lots of different things that I can do. Well, one of the things that I'm noticing about mine is that there's a fair amount of white space kind of on the left and right side of it. If I can crop away that white space, I can actually increase the size of the image without bumping into some of the text here. So I'm going to use the crop tool. Crop tool is located right over here on kind of the right end of the ribbon bar. And when I click the crop tool, you'll see that these black guides appear all the way around the image. Now to crop out this white space on the right side of the image, I'm just going to grab one of those guides and slide it in. Now notice I'm doing this from the sides, and I told you before to never resize from the sides, and that still stands. That rule still stands. But what we're doing here is not resizing, we're cropping. We're just getting rid of some of this white space. So I'm going to get rid of a little bit of this white space at the top and some of this in the back here. And with that, I now have a more tightly cropped image. When you're done with your cropping, you're going to click the crop button again, and then that will actually cut that stuff out. So now what we're left with is really the image without that crop stuff. Now what I can do, that allows me to make my image a little bit bigger, but without having all that white space interfering and bumping into the text. Okay, so cropping is that button is really a valuable one. Anytime you're bringing in images that were not really designed for what you're doing, but you're just going to try to make them work there, that crop button gives you a lot of control over how the image is ultimately going to appear. Or there may be something in the image you want to get rid of. For example, this image here says the right way, the wrong way. If I didn't want that, I could use my crop button to get rid of that. So if I didn't want that text, I could just crop it out, and now I've got everything but that text in there. Okay, so if there's something in the image that you don't want that you're able to crop out, this gives you that ability to crop it out. Usually whatever that image, whatever that thing is, has to be like around an edge, though. You're not going to be able to crop something out of the middle of the image very easily. All right, once you have your image in place, now we can go ahead and actually do some color stuff here with our spreadsheet. So I'm going to take my spreadsheet, I'm going to take kind of the bulk of it here and highlight everything, and I'm going to assign a background color to the entire background. I'm going to use this using my little paint bucket tool. And I'm going to give it kind of a light gray. I'm actually going to give it kind of a similar color to what we have maybe with these headers, maybe slightly darker to set it off just a little bit. Now my input values, again, I really want to make it clear that this is a place where we can type stuff into the spreadsheet. And I'm going to do that by using my paint bucket tool, and here I'm going to use no fill as my option. So here I'm basically going to kind of cut holes in that in that color. So now what we have is this white space where it's clear that you can type stuff in. That combined with the blue font essentially should make it obvious that this is where we can type our stuff. Once we're done with that, we'll go on to the next step, and our next step will be to clean up the background of the spreadsheet a little bit. Now this is something we can actually do pretty easily. Now the spreadsheet by default has these grid lines on it, and the grid lines are valuable when you're working with the spreadsheet because obviously it allows you to figure out where the cells are and just makes it a little bit more accurate when you're clicking and selecting to have those visual guides. Now what we're going to do though is we're going to get rid of them because now we don't really need them anymore. We've kind of built everything. The formulas are all there. It's clear where everything is going to go. So what we're going to do is turn off that grid pattern, and what you'll see is as soon as you do that, it really changes the appearance of the spreadsheet considerably. So to do this, we're going to go up to the View tab. Once on the View tab, there's a checkbox for grid lines, and we can go ahead and uncheck that. And as soon as we do, the grid lines all go away. Now what we're left with is this really nice, clean looking spreadsheet. Now at this point, we can do a little bit of touch-up, and this one I'm going to leave it to you to be a little bit creative, but a couple of the things I'm going to do, for one thing, I've noticed that I've got this little white blank space here where I kind of came up short on my little background color, so I'm going to go ahead and fill that in, just make it a little bit even. Compression force and PSI, this is kind of a important thing. This is the results of the whole thing. I'm going to go ahead and bold that, make it stand out a little bit, and in fact I can even put a border around it. So if I select those cells from D1 to F7, I can use my border tool over here, and it's located just to the right of the underline button there. And notice one of the options, outside borders or thick outside borders. Well, I can try them both and see how they look. I'll try the thick one first, and I think the thick one looks pretty good. It seems to really make that stand out, so it's pretty clear. And I think I'll do a thick outside border on my status as well. All I have to do is come over here to the border button. It remembers the last thing I selected, so I just have to click it. And there's my border on the status. So now we've got these nice borders around it, again kind of making the final bottom line stand out a little bit. Now at this point, it's time to get creative. If there's anything else you would like to do with your spreadsheet, now would be a good time to do it. There are some other things we could do, but I think we're going to stop it right about here. This gets some of the key ideas across that I wanted to cover in terms of some of the specifics. So in this exercise, we introduced logic formulas, which we did using the if function, and we actually nested the if function down to 2 levels. That's a really important one. You will need to be able to explain what an if function does in terms of the final, so make sure you really understand what that if function does and how it works. We also worked with formatting a little bit. We brought in some images, we cropped the image, we resized an image, and we kind of messed around with some color and and formatting. So again, I'm going to leave it to you as to what else you might do, and as you get creative with it, I just found something here that I think I'm going to do, and that's to kind of remove the fill from that column C just to set everything off a little bit. Go ahead and spend a little bit of time with it, and when you're done, what you can do is to go ahead and submit this. So there will be a submission option that I'll set up for you in Canvas. So this will be for the back compression forces model, and this will be the lab exercise for the week. The next thing to do after this one will be to do the lab assignment in the Cognilla Active Learning System. So that lab assignment, as a reminder, I mentioned it in class, but that lab assignment essentially will allow you to create a spreadsheet that will estimate your target heart rate under exercise, so under varying assumptions and for different ages and so forth. And it's very much similar to some of the things we did here, but it's going to be a bit more advanced still. So it will introduce VLOOKUP functions and along with the list boxes and in combination. So this one's it's going to be a little more advanced, a little more complicated. Make sure you understand what we did here before you go on to that one. If you don't quite get it, if the idea of the logic function didn't quite make sense to you, or the drop-down list didn't make sense to you, make sure that you get it. Go back and review it, redo it again if you have to, rebuild the whole spreadsheet again from scratch if you have to, because it's really important that you understand the concepts, not that you just followed along and were able to mimic what I clicked on and what I typed, because that doesn't really mean you understand anything or you're able to duplicate it yourself or apply it to a different situation. For the final, you will need to be able to take these concepts and apply them to an entirely different situation. So that's kind of what we're working with. Okay, so with that, we are done with the spreadsheet. Save it, and congratulations, you now can calculate your back compression forces when necessary. And I'll look forward to seeing the results and to seeing you all in class.